In today's lesson, we'll be learning about the Pythagorean Theorem. The Pythagorean Theorem is a relationship between the side lengths of a right triangle. If you recall, a right triangle is a triangle that has a 90-degree angle. We use a little square to indicate that 90-degree angle. Both A and B are considered legs in a right triangle. Meanwhile, C is considered the hypotenuse. The hypotenuse is opposite to the 90-degree angle, and it is the longest side in a right triangle. Therefore, if we take a squared and add it to b squared, we get c squared. In our first example, we want to determine the length of the hypotenuse. If you take a look at the diagram, we have a right triangle. However, it doesn't have any labels. Remember, A and B are the legs of the triangle. So I'm going to call this A, and I'm going to call this B. The hypotenuse is C, and that is what we're looking for. Let's begin by rewriting our equation, which is a squared plus b squared is equal to c squared. Next, we want to substitute in our known values. And we're going to do that in brackets. So I have 6 squared plus 15 squared, and that is equal to c squared. Let's simplify some of these numbers. 6 squared is actually 6 times 6. A common misconception is that it is 6 times 2. 6 times 6 is 36, and 15 squared is 15 times 15, which is 225. Everything else on the right side stays the same. Please don't forget that squaring something is not multiplying by 2. It is multiplied by itself. Therefore, 36 plus 225 is 261, and that is equal to c squared. But we want to figure out what c is equal to. Therefore, I'm going to have to get rid of this square. To do that, I'm going to square root both sides, and you're going to need a calculator to do that. The square root of 261, when rounded, is about 16.2. Therefore, the hypotenuse is actually 16.2 meters. So let's write a concluding statement. Therefore, C is 16.2 meters. In our second example, we want to determine the length of the hypotenuse. The first thing you want to do is label the diagram. As you can see, we've been given the measurement of the legs of the right triangle. So I'm going to call this A, and I'm going to call this B. We want to figure out the hypotenuse, so I'm going to call that C. Our first step is to rewrite the Pythagorean theorem, which is a squared plus b squared, which is equal to c squared. Next, I want to substitute in my known values with brackets. So a is 7 squared and b is 10 squared. Remember, when you're squaring something, you're multiplying that number by itself. You're not multiplying by 2. So 7 squared is 7 times 7, which is 49, and 10 squared is 10 times 10, which is 100. And everything on the right stays exactly the same since we haven't done anything to it. 49 plus 100, that's pretty simple. That is 149, and everything on the right stays the same. Remember, you want to figure out what c is equal to, but I have c squared. To get rid of the square, you need to do the opposite operation, which is a square root. So I'm going to square root both sides of the equation. You're going to need a calculator to find the square root of 149. So when you put that into a calculator, it is going to be equal to approximately 12.2. So I'm going to write a therefore statement. Therefore, C is about 12.2 centimeters. In our third example, we want to determine the length of the leg. If you take a look at our diagram, we've been given the hypotenuse, we've been given one of the legs, but we haven't been given the other leg. So that is what we're going to be looking for. Let's begin by rewriting the Pythagorean theorem, which is a squared plus b squared, which is equal to c squared. I'm going to substitute in my known values in brackets. So I'm going to put 10 in brackets over here. I do not know what b is, so I'm going to leave that alone. I do know what c is equal to. C is 17. I'm going to put that in brackets. Remember, when you're squaring something, you're multiplying that number by itself. You're not multiplying by 2. So 10 squared is 10 times 10, which is 100. B squared hasn't changed. And 17 squared is 17 times 17, which is 289. Remember, you want to figure out what b is equal to, but b is stuck with this 100, this positive 100. To get rid of it, you need to do the opposite operation. So you need to subtract 100 from both sides of the equation. So I'm going to go 100 subtract 100. Everything else stays the same. And I'm going to subtract that from the other side. 100 subtract 100 cancels out because that becomes 0. And all you're left with is b squared. And 289 subtract 100, that is 189. Remember that you want to figure out the value of b, but we have b squared. To get rid of the square, you need to square root both sides of the equation. So that just becomes b, and the square root of 189 is approximately 13.7. You're going to need to use a calculator to do that. So I'm going to write my therefore statement over here. Therefore, b is 13.7 meters. In our fourth example, we want to determine the length of the leg. So let's take a look at our diagram. We've already been given the value of the hypotenuse, so I'm going to name that c. We've been given a variable for one of our legs, that's r, so I'm going to say a is equal to r, and down here I'm going to say b is equal to 15. So we're going to begin with our Pythagorean theorem, which is a squared plus b squared, which is equal to c squared. I'm going to substitute in my known values now. So instead of writing a, I'm going to write r. And for b, I'm going to put 15 in brackets. And for c, I'm going to put in 23.25 in brackets. Let's simplify some of these numbers. So the r squared stays exactly the same. 15 squared is 15 times 15, which is 225. And 23.25 squared is approximately 540.56. You can put a couple more decimal places if you want. I'm only going to be using 2. You're going to need to use a calculator to do that, by the way. Remember, you want to figure out what r is equal to, but r is stuck with this positive 225. So to get rid of it, you need to subtract 225 from both sides of the equation, and that's what I'm going to be doing. So 225 subtract 225, that cancels out, and all you're left with is r squared. Meanwhile, 540.56 subtract 225 is 315.56. Remember, you want to figure out what r is equal to, but r is being squared. So to get rid of the square, you need to square root both sides of the equation. You're going to need to use a calculator to do that. So the square root of 315.56 is approximately 17.8. So I'm going to write a concluding statement. Therefore, r is 17.8 units. There is no units specified, so you can just leave it blank. In example 5, a vehicle's hatch opening measures 95 centimeters high and 110 centimeters wide. Do you think a round table with a diameter of 140 centimeters will fit through the opening? So the first thing you want to do is do a rough sketch. So the hatch of this car is probably rectangular in shape. It measures 95 centimeters high and 110 centimeters wide. We want to know if a round table with a diameter of 140 centimeters will fit through the hatch. So what we need to do here is we need to determine if the hypotenuse here is equal to 140 centimeters, or if it's bigger, or if it's smaller. So that's what we're looking for. So let's label our diagram. That 110 centimeters is going to be a leg for that triangle. 95 centimeters is going to be another leg for that triangle, and the hypotenuse over here, we're going to label that C. Let's begin with the Pythagorean theorem. So I have a squared plus b squared, which is equal to c squared. I'm going to substitute in my known values, so I have 110 squared plus 95 squared, and that's all equal to c squared. So at this point, you just need to throw these numbers into your calculator. So 110 squared is 12,100, while 95 squared is 9,025. Everything on the right stays the same. So let's simplify some of these numbers. So let's add 12,100 and 9,025 together, and you are going to get 21,125. That's going to be equal to c squared. But we don't want to figure out what c squared is equal to. We want to figure out what c is equal to. So to get rid of the square, we have to square root both sides. So you're going to have to throw that into your calculator, and you're going to get approximately 145.3. That's going to be equal to c. So because the hypotenuse is 145.3 centimeters long, and the table is 140 centimeters long. Therefore, it is going to fit. So let's make a concluding statement here. Since the hypotenuse is 145.3 centimeters, therefore the round table will fit into the car. In our last example, a television that has a diagonal length of 60 inches measures 52 inches along the top of the screen. What is the height of the screen? So let's begin by doing a rough sketch. So a TV is rectangular in shape. It has a diagonal length of 60 inches. And it has a width of 52 inches. But we want to figure out the height. Let us label what looks like a right triangle. So 52 inches is one of the legs. The height is going to be also one of the legs. And 60 inches is going to be the hypotenuse. We begin with our Pythagorean theorem. So I have a squared plus b squared is equal to c squared. So I'm going to substitute in my known values. I'm going to put 52 in brackets. I'm just going to leave b squared alone, and c is 60 in brackets. Let's simplify some of these numbers. 52 squared is 2,704. The b squared is going to stay the same. And 66 squared, or 60 squared I should say, is 3,600. Since we are solving for b, we need to isolate it, but b is stuck with this 2,704, which means we're going to have to subtract 2,704 from both sides of the equation. So 2,704 subtract 2,704 cancels out, which leaves you just b squared, and 3,600 minus 2,704 is equal to 896. But we want to figure out what b is equal to, so let's get rid of the square. To do that, we need to square root both sides of the equation. So 896 squared is approximately 29.9 inches. So let's write a concluding statement. Therefore, the height of the TV is 29.9 inches.